In this video, we're going to cover two terms you'll hear constantly in networking, LAN and WAN. We'll also go a bit deeper on packets, how data actually moves across a network. By the end of this 5 minutes, you'll have a solid mental model for what happens when a PLC sends data to a historian sitting in another building or another city. Let's start with a LAN. LAN is a local area network, which is a network that covers a single site or building. Think of your plant floor controlled network. All the PLCs, HMIs, workstations, and switches in the same facility, all wired together. The key characteristics of a LAN are that it's fast, it has very low latency, and critically, you own and control the entire thing. Every cable, every switch, every device on that network is yours to manage. That's important from a security standpoint. You have full visibility and control over what's on a LAN. A wide area network, on the other hand, spans multiple sites or long distances. Where a LAN might cover a single plant, a WAN might connect that plant to a corporate office, a cloud historian, or a control center 200 miles away. The big difference from a LAN is that you're typically not owning the infrastructure in between. You're leasing it, using a fiber service from a carrier, or running over the internet. That introduces factors outside your control. Other organizations sharing the same infrastructure, variable latency, and less visibility into what's happening in transit. In the last video, we talked a little bit about how packets move and what packets are. Let's talk just a little bit about how they get from point A to point B. When your SCADA system sends data, it gets broken into packets, each labeled with a source and destination address. Those packets are then handed off to switches and routers, which we'll cover in the next video. And those devices make decisions about where to send each packet next. Here's an important characteristic. Packets can take different routes to the same destination. If one path through the network is congested or down, packets can reroute automatically, and then they reassemble in the right order once they all arrive. This is what makes IP networks resilient. There's no single path that everything depends on. It's similar to, let's say you had a group of people that you wanted to meet for dinner somewhere. Maybe you're all leaving from the same place. You want to arrive to the same place, but you can each take different routes and you will join up and meet back together and reassemble at that destination. Next up, we're going to look at the hardware that makes all this happen. Switches and routers. You've probably seen these devices in your control room or network cabinet. We're going to explain exactly what each one does and why it matters.